Today we are going to talk about an important law with respect to chemistry of solution. The law is known as Raoult Law. Which was proposed by a French chemist in 1887. He was a French chemist. Simple expression for Raoult Law can be written as P is equal to P naught X 1 or whatever the mole fraction is. This equation states that the vapor pressure of a solvent in solution is equal to the vapor pressure of a solvent in pure state multiplied by the mole fraction of the solute dissolved in that solvent. So P is vapor pressure of solvent in solution state. P naught is the vapor pressure of solvent in pure state, and as far as X is concerned, this is the mole fraction of solute. Before addressing this equation in detail, what exactly it stands for, we need to focus on some important example. Especially we will consider the example of antifreeze. So that we could clarify the above equation. Antifreeze is basically a substance or additive which is used to aid to the radiator of a vehicle, especially in those areas where temperature falls down below 0 degrees centigrade. So in such region there is a chance that the water used inside the radiator can be frozen, and ultimately when it's frozen and the volume of the freezing ice become to expand, and that can put an immense pressure on the radiator rod, and ultimately they can collapse under the pressure. So in order to avoid this danger, antifreeze is added so that and the freezing point of the water is lower down below 0 degrees centigrade. For example, we have used water inside a radiator which is in pure state. So let's suppose its vapor pressure in pure state is P naught. Then in the second case we add an antifreeze. In other words, we make it a solution. So after making solution, the vapor pressure of the water will be P. As far as the mole fraction of antifreeze is concerned, that can be written as X1, which is a solute that is adding to the solution of water. So generally we can say that when the water is in pure state, it can easily evaporate, or it has a vapor pressure that can be greater, or it is greater than the vapor pressure of the same water once it makes a solution. So this relationship has been expressed by Raoult Law, which states that the vapor pressure of a solvent in solution is equal to the vapor pressure of the pure solvent multiplied by the mole fraction of X. If we increase the quantity of antifreeze, or we add a greater quantity of antifreeze, or increase the mole fraction of antifreeze into the radiator of the vehicle, greater will be the depression in freezing point. So this is the general equation which tell us a mathematical form of this relationship, that how it expresses. the Raoult Law. So depression of freezing point is a colligative property. Colligative properties are those properties which depend upon the number of particles or solute particles rather than their nature. We can have different type of colligative properties while studying the chemistry of solution. For example, elevation of boiling point, depression of freezing point, of Mortec pressure, etc. So these are different colligative properties which depend upon the number of solute particles rather than their nature. As far as the Raoult Law is concerned, we have two quantities in solution here. In this case, just in second case after making its solution, we have two quantity. This is the mole fraction for, let's suppose, water, and this is the mole fraction for a solute, that is 2. Their summation is always 1. So the mole fraction of all the component is unity. In order to arrange the equation for x1, we can write x1 is equal to 1 minus x2. Putting this value in above equation, we can have p is equal to p naught 1 minus x 2 . So here this equation 1 and this equation 2 offer an important definition for the Raoult Law. As far as the equation 1 is concerned, this means that the vapor pressure or the lowering of vapor pressure, especially when you make a solution of particular solvent, definitely vapor pressure will be lower down. So delta P is the lowering of vapor pressure. This is lowering of vapor pressure of water. So the lowering of vapor pressure is equal to the vapor pressure of the solvent in pure state multiplied by the mole fraction of the solute. If we increase the quantity of solute, the lowering of vapor pressure will be greater. As far as equation 2 is concerned, the ratio tells us about the relative lowering of vapor pressure, which tell us that the relative lowering of vapor pressure is equal to the mole fraction of solute. Again, the solute fraction is telling an important relationship. Its quantity can express whether the lowering of vapor pressure will be greater or lower. So this is all about Raoult Law that tell us about how the vapor pressure of one component decreases with respect to a mole fraction or the quantity of solute which we introduce into the solvent. Furthermore, we also studied about colligative properties. Colligative properties basically are those properties which depend upon the number of solute particles rather than their nature. So whether there is elevation of boiling point or depression of freezing point or osmotic pressure, all these are colligative properties.